Okay, class, welcome back. We are going to continue our discussion over units of measurements and conversions with chemical compounds. Our next unit of measurement we are going to talk about is atoms and molecules. Our goal for today is that we will be able to quantify the relationship between moles and atoms/molecules. In saying that, let's dive into this quick lesson. In our last video, we discussed the relationship between formula mass and moles for a compound. Now we're going to take this a step farther and give you another relationship you can use with your conversions and moles. Today we're going to talk about atoms and molecules. In the simplest form, all these mean the same thing, just in different types of substances. And atoms are for singular elements like carbon, while molecules are for compounds like carbon dioxide. No matter if we are talking about atoms or molecules, we are going to be still using and talking about Avogadro's number. You're going to be using this number so much that you might as well memorize it. Avogadro's number is 6.022 times 10 raised to the 23rd power. Basically, whether we are in a single element or a complex compound, there are 6.022 times 10 to the 23rd power of particles within 1 mole of that substance. So 1 mole of aluminum has 6.022 times 10 to the 23rd atoms of aluminum, and 1 mole of glucose, which we remember from our last video is C6H12O6, is still 6.022 times 10 to the 23rd molecules of glucose. Because of this, we're going to use these shortcuts when calculations involve the number of atoms or molecules. If we are given the moles and want to convert to atoms or molecules, then we're going to use the relationship of Avogadro's number over 1 mole of that substance. If we are given the number of atoms or molecules and we want to find the number of moles of that substance, then we're going to do 1 mole of that substance over Avogadro's number. Helpful hint though, when calculating these, make sure you always put Avogadro's number within separate sets of parentheses so that you don't mess up your calculations. Now let's work through a couple practice problems. How many molecules of water are within 3 moles of water? So I would first write down what I know over 1. So that would be 3 moles of water over 1. Next, I would multiply my 3 moles over 1 by one of my relationships stated above. I'm wanting to convert from moles to molecules. So I'm going to use the relationship 6.022 times 10 to the 23rd molecules of water over 1 mole of water. At this point, I'm going to multiply my tops and bottoms, then divide out. So 3 moles times 6.022 times 10 to the 23rd power would be 1.8066 times 10 to the 24th molecules of water. Our bottoms would then multiply 1 by 1, which gives us an answer of 1. So now we take our top number and divide it by our bottom number, and we get 1.8066 times 10 to the 24th power of molecules of water. Here's another question. How many moles of silicon are in 1.022 times 10 to the 20th atoms of silicon? Setting up our equation, we write down what we know over 1 first. So this is going to be 1.022 times 10 to the 20th atoms of silver over 1. Next, we multiply by our relationship of 1 mole of silicon over 6.022 times 10 to the 23rd atoms of silicon. Now we multiply our tops and we get 1.022 times 10 to the 20th power, and we multiply our bottoms and we get 6.022 times 10 to the 23rd power. The last thing is we divide these numbers out. Make sure you are using your parentheses in this one. So I'm going to show you on the screen how I would type this in. So here we go. I would type in open parentheses 1.022 times open parentheses again 10 to the 20th power close parentheses again divided by open parentheses 6.022 times open parentheses again 10 to the 23rd power in parentheses twice, then I would hit enter. If you did this right, you will get 0.00017 moles of silicon. If I'm writing this in scientific notation, this would be 1.7 times 10 to the negative fourth moles of silicon. Okay, so now you should be able to go back and forth from moles to atoms or molecules, and from moles to atomic mass or formula mass. Pretty soon we're going to bring both of these components together and start solving more complicated chemistry problems. So in other words, we might be going from formula mass down to number of atoms. But until then, keep up the good work. Just be able to crank this stuff out. Just take it one problem at a time, one step at a time.